We'll proceed in summation and integral. Okay, so summation and integral calculus, the topic in which we are pursuing the discussion. Summation and integral calculus. Okay, whenever it comes summation and integral calculus, it is highly natural that probability statistics will come into the picture because summation is considered a discrete value, whereas integration is considered as continuous value. There is no integration for the discrete value. What is discrete value? What is continuous value? That we have seen. Okay, one simple example I can take. How to convert discrete value into continuous, that is the art where the someone has to learn. Then integration is a cakewalk only. What is discrete? Consider that this is a stick. This is a stick, and then it is of length 1. This stick is of length 1. And now, I cut this stick at any part. I'm sorry. I have a axe, I have a knife, and I hit the stick at any position and cut it into two parts. Okay. Now, consider that what is the probability? What is the probability? Hop. I would rephrase this. Okay. Now, question is arising that if I have a stick and then I make a cut on this stick, if I have a stick, then I make a cut on this stick. Wherever I cut, left part I collect it and right part I throw it. I cut at one place, left part I collect it and right part I throw it. Okay, I have many 1 unit length stick in my collection. I have a collection of many, innumerous. I have an innumerous collection of 1 unit length stick. Idea is that I have an axe or knife and then I place axe or knife anywhere. There is no reservation out here. There is no privilege out here. I put and whatever I cut the left part, I keep it and right part I throw it. Now I have pull off left part what I cut. What is average length of this? That is the question mark. Okay, the best solution for this is there are two solutions to it. One is called discrete solution, one is called continuous solution. What is discrete solution? Discrete solution is that consider this is 1 unit. I make n division into it. Makes sense? N division. Where n can be 2, n can be 10, n can be 100, 1000. Okay. If it is 10, I have made 10 division of this stick. So this is 1 by 10, 1 by 10, 1 by 10 like this. I have 10 section now. 10 division or 10 demarcation I have made. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will go at the end. First part, second part, third part. Okay. Now I in that fashion, if I hit, then hit will fall in any of the sections. How to find average length of the first part? Okay, probably that I should talk more in detail. How to find the average? Anyone would say that calculate the length of all the cut down sticks left part. Okay, and then you add all the length divide by number you have. Okay, if there is 10,000, then is it possible that 10,000 stick someone would count and measure exact length and then divide by 10,000? It is difficult. So what people will do now, they will make a cut into n part. Suppose 10 part, they make a cut into 10 part. Okay, now whenever axis comes, it will make a cut in one of the part. Okay, so consider this is the ith part and this width of the ith part is 1 by n. If its length is 1, then width of this is 1 by n. If length is 10, then this width is 10 by n. Okay, now I have so many sticks that is cut down. Okay, I'm asking someone, can you make a graph of the length? What is the graph? Graph talks about the length of all the stick that is cut down. They fall in one of the n section. If this is length 1, and I divide into 10 different parts, they will fall any one of the 10 parts. First part, second part, third part, fourth part, fifth part, sixth part, seventh part, eighth part, ninth part, 10th part. My cut will fall in any one of the parts. Okay, now consider I have alpha number of sticks. Then he will make a graph. In first cut, how many sticks are there? In first cut, if there are 10 sticks, then he can just write 10. Next cut, 20. Next cut, 5. Next cut, 40. Okay, like that. If I add all the bar height, it will come to alpha. I have alpha number of sticks. Then in the first section, if I cut it, then it will be how many it is coming there. How many it is coming there. Okay, that is the kind of scenario. So what is the average length? Then this length, that is the first section. This is second section. What is length from here to here in second section? If I take till n, then it will be 2 by n. The length of the second section is 2 by n, and into the how many are piled up there. How many are piled up there? Makes sense? Okay. Then we go the third section. Length is 3 by n. 3 by n. And how many are piled up there? Okay. We keep adding it, and then we get the total length. Length 1 plus length 2, length 3. So if I have a graph of 10 sections, and then I have the bar chart against each section, then it is pretty easy to calculate the, it is pretty easy to calculate the kind of the net length. If I am in fifth section, first section, fifth section. If I am in fifth section, then the length is 5 into it will be 5 into 1 by n. One length is 1. So the length will be 5 into 1 by n. 5 by n into the height. How many are there in this section? How many sticks are there in this section? You just keep adding it, and you get the total length. Divide by alpha. That is the number of sticks. If probability manner. Okay, if I talk about the probability. Okay, if I talk about the probability, I believe I am all right. If I talk about the probability rather than the number of sticks are in first column, second column, third column, fourth column. In the fourth column, the number of sticks are 20 and number of total sticks are alpha. Then getting here, the probability is 20 by alpha. Makes sense? We are talking about discrete notation. What is discrete notation? Discrete summation to integral. This is the topic we are pursuing. Summation means discrete summation. This is typically called discrete summation. Discrete summation means I have divided my stick into discrete manner in 10 parts. If it is continuous, then it is in numerous parts. If I take any point, it can be anything. Anything means 0.0.6999998. That is the distance from here to here. Okay. But if I divide into discrete manner, okay, and how many sticks are there? Then stick is a graph. Stick is a graph. Makes sense? If someone understands this, it looks cumbersome. But if someone understands the relationship between digital and continuous, this is same as that someone talk about FET, field effect transistor in electronics. Field effect transistor talks about two levels at the collector section. There is no collector section out there. Field effect transistor, I believe it has another notation of the base, emitter, and collector. But collector voltage in the field effect transistor, it will be either 0 or 1. Either it will be no voltage. Zero means it's not that it is 0 volt. 0 means it will come to, I believe, if it is up to 0 to 5 volt, then 0 volt will be up to, I believe, 1.3 volt or something like that. And 1 means it will go beyond 2.3 volt or something like that. Then it will be 1 or it will be 0, whatever it is. So voltage level at the collector of the field effect transistor, it will be 0. 0 means it will be below some minimum voltage level. It is considered as 0. Or it will be 1. Above some 1 threshold, it will be above that. It is digital. Okay. Or if it is a BJT bijunction transistor, or someone can say bijunction diode also. So BJT, if it is BJT, then collector voltage, if it is can go from 0 to voltage at the collector battery that is connected at the collector is 5 volt, then it will go 0 to 5 volt. Any smooth line it will go. It has innumerous values, that is continuous, whereas FET, field effect transistor, it will have only in range of two ranges only. So in abstract manner we say either it is 0 or 1. If it is above 2.3 volt or I believe 3.3 volt. If it is above 3.3 volt or 3.7 volt, 3.3 volt, whatever it will be considered as 1. If it is below 1.3 voltage, whatever it will be considered as 0. If it is in between that, it will be considered as error, or through some algorithm they will try to find out it is matching to 0 or 1, whatever. Similarly, if I am trying to find a solution that what is average length of a stick, that I cut down a stick at any point, and what is average length here? In discrete manner, I divide this stick into n parts, and when I cut it, I make sure that it will cut in one of the parts. Okay, then I throw it. So when I cut, now if I take a stick by stick, then I just check that stick length belongs to which part, which I is 1 to 10. Consider I divided into 10 parts. This is the unit length I divided into 10 parts, n equal to 10. Okay, if I take one stick, then I see it belongs to which part. Then at this part, I mark it 1 because I found one stick. Then I take another stick, and it is coming to same part. Then I mark it 2. I take another stick, and it coming to same part, ith part. I mark it 3. Like that, I make a full chart. I have a chart ready. This is x-axis. Then against each section, that is 10 in number, I have a bar now. This is typically called discrete value. What is the average length of the stick that I have collected? Then what is the average length of this first part? If this is 0 to 1, I'm sorry, 0 to point 1, the length I'll consider as length I'll consider as 1 by n. N is 10.1. 0.1 into height, 0.2 into height, zero point 0.3 into the height in the third section. How many sticks are there? If I add all, I get the all length of the stick. Adding length of all the stick, that data I get. Divide it by number of the stick, then you get the average length of the stick. Or whenever I see or I draw the graph in a fashion, consider in the first section the stick count. Total number of stick is alpha. Consider in first section the stick count is 10. Then I'll write, instead of 10, I'll write 10 by alpha, because probability of getting here is 1 by 10 by alpha. Here it is 20 by alpha, like that. Now this distance 0.1 into 10 by alpha. This distance 0.2 into 20 by alpha, like that. If I write in this fashion, no need to divide by the net length, that is alpha, because we are already dividing in all the sections. This way we calculate the average length. What is average length? Average length is distance into probability. Make sense? Distance into the probability of that section. Okay, those are the height. These heights can, if I match this height with a point, then it will draw a line. That is a function for the discrete distribution. That is not a function for the continuous distribution. There is a continuous distribution, that is different. Okay, someone would say, okay, now if I touch all the 10 points on top, it draws a line. Oh, I got the formula. If draw a line, then if I take any point out here, if I take any point out here, then I can know that how many sticks are there. No, no, that is not the that is not the concept. Because if you draw a continuous line and take any point, that continuous line is a formula for the discrete one. Formula for the continuous will be different. Consider that I draw what is the kind of resemblance in both of them. If I draw a discrete formula and if I draw a continuous formula, what is the resemblance in them? The resemblance in them is for discrete. This discrete, if I talk about the discrete, then if I add all the height in the discrete, just height, not multiplied by this length and multiplied by this length, just if I add all the height in the discrete, it will be 1. Makes sense? Similarly, if I have a continuous line, if I have a continuous wave, like this is distributed like this, if I have a continuous line, then if I calculate area underneath it, then it will be 1. So if this discrete formula is fx and then continuous formula is gx, then fx equal to gx dx. Makes sense? Please watch our 3-4 days back the video how to convert discrete into continuous. But this is what the story of the discrete and continuous. I believe it is too much time we have spent on this. I'll take down one problem. Then we'll come to the problem in conditional statistics and those things. I had a very famous problem I had taken, that there is a prize money. There is a prize money, and prize money is kept behind 3 doors. There are 3 doors: one door, second door, third door, and there is a prize money. Not the prize money someone won in the competition. Someone went and write something in competition or played a kabaddi or kho in India, or he is playing American football or whatsoever. All are very good. So American football or whatsoever, and then he won the prize, and now someone is saying prize is behind the door, then he will feel very bad about it. So I am saying there is a lucky draw. Lucky draw is going on. Lucky draw is going on, and prize is behind the 3 doors. There are 3 doors, and prize is behind the scene. If price is behind the scene, then I'm asking a person that you have to first you pay some money. Okay, minimal money. Okay, he is paying the minimal money called lucky draw money. He is paying lucky draw ticket. Okay, once ticket is paid from him, now I am asking, go and try your luck. Okay, now he consider he is opening a door. There are three doors. He is opening a door. Consider he is opening door number 1. Considering that prize money, the lottery prize money is behind the door. Idea is if there are 3 doors, the lottery prize money is behind one door. He is paying for a lottery ticket. Now he is bringing the ticket. Now I am asking him, go and choose one door. He went and choose the door number 1. Behind the door number 1, prize is there, prize may not be there. No, he's just holding the door now. He's not opening it. He's just touching the door number 1 at the handle of the door number 1, thinking that if it is getting open, now the organizer will come and he will put the key there. Once he put the key there, then door will be open. Now he has to see his luck that prize is there or not. Okay. Now the organizer is very kind of a kind-hearted person. Now he is giving a chance to that person. So chance to that person is when he is holding one door, then in next two doors there is a guarantee. In next two door there is a guarantee that one door does not have the prize money. I believe I'm all right. If there are 3 doors, one door, now door number 1, the contestant is catching now. That prize lottery money is behind it. He is catching now. Now it is guaranteed that in other 2 door, in one door prize money is not there. That is guaranteed. If this has prize money, then one of them does not have, both does not have prize money. If this does not have prize money, then again one of them does not have prize money. That is guaranteed. Now organizer is coming and he is putting a key in one of the rest of the door, and he is showing the door that prize is not there. Then immediately to the contestant, it is hitting his mind. He is catching one door and he is seeing that in one of the door, prize is not there. Means prize is either in remaining one door. If the organizer is opening door number 2 and saying that prize is not there, see. Now, in the contestant mind, it is 100% sure that prize is either behind door number 1 or behind the door number 3. That is guaranteed. Now, it is beneficial for him to switch to door number 3 or remain in door number 1 only. That is the question. Okay, this falls in discrete analysis. There can be continuous analysis also. What is discrete analysis? What is continuous analysis? We will carry this discussion, because if someone really understands this, he can use calculus. We will try to bring vector also in this discussion. If he can use calculus, then he can get exact solution. Discrete analysis may not give exact solution. Okay, like here in digital world, the actual question was, what is the average length of this stick? What is the probability that you will cut at a particular section? Anyone would ask, what is the average length of the stick? If I take the first part, if I cut down at any part, the probability of cutting down at in any location of the stick, unit length stick, is same. What is the average length of the stick? That is under question mark. When he is measuring the stick, then in each section, when he had divided into n parts, each section, he is raising a bar, that what is probability of this section? What is probability of this section? Then he is adding this length into this bar, this length into this bar, this length into this bar, and then he is adding it and he is saying this is the probability. What is the answer? This is called discrete methodology. Anyway, so what is the answer here? That a person who is holding a door, an organizer is showing one empty door to him. Probably the door he is holding, prize is not there. Prize is in the third door. So organizer is opening second door and he is showing that prize is not there. Now, should he switch from first door to third door? Okay, considering that if prize is not there in the second door, prize probably in the third door. Then he is thinking, if I have been given a chance to switch, then I can switch between one and third. Second does not have prize. In that fashion, getting the prize money, again the probability is one. Earlier the probability of getting a prize in any door was 1 by 3. When he has opened the door where prize is not there, getting prize money in any of the two doors is 1 by 2, and it is same in both locations. Either you keep holding this or you go to the third door. The expectation is same, 1 by 2. Then why to jump here and there? Unnecessary. Okay, he will keep holding the first one. Or prize money is in first only. Then he is opening third one. Then now it is coming to his mind. Prize is either in first one or second one. Should he switch? Okay, if he switch, then what will happen? Now he is thinking, even if I switch, then it is as good as prize is in first or second. Then there is no big deal. Okay, we will talk about magic of discrete or repeated summation we are talking. And the integral calculus work in continuous graphs only, not on the discrete graph. So if I'm trying, first will the concept, the algorithm is, first try to get the this is not available in any of the book. The stick example what I have given, it is available in the book. Example is given, but solution is directly into integration, directly into calculus. Whenever someone is facing a problem, try to solve the problem. Try to solve the problem in discrete manner only, and then make n tends to infinity. When someone has divided the problem into n parts, discrete to integral, divide the problem into n parts and try to solve for the each part and then assemble it. While assembling it, make assumption n tends to infinity. Then whatever the discrete function someone has got it, he has to convert discrete function into analogous function, and then only he can calculate the integral. But make sure that if someone takes the discrete, the probably he is getting the summation of all the probability. Summation of all the probability is same as if I have a continuous function, the area underneath the continuous function. That is required. Anyway, I have another question now. Okay, there is a coin. There is a coin. Okay, a person is, I am standing at one place. I am standing at 0. This is x-axis and this is minus x-axis. Okay, this is x-axis and this is minus x-axis. This is origin. This is origin and this is x-axis. This is minus x-axis. Person is standing here and he is tossing a coin. In his hand, he has a coin. If it comes tail, he will make one step forward along x-axis. Then he is getting head again. If he gets head, if he gets head again, he will move forward. Okay, rather than writing this problem in this fashion, person is standing here and he has n number of coins in his hand, n number of coins. Now he is throwing the coin. Okay, if number of head are 5, then he will move 5 steps. If number of tail, then number of tail are n minus 5, then he will move n minus 5 step behind. Okay, that is the scenario. Okay, first he is moving. Now he is seeing the number of head. He is throwing a coin and he is seeing the number of head. Number of head is, the number of coin is n. Number of head he is seeing is 5. Then he made 5 step forward. Then number of tail he is seeing, obviously it is n minus 5. N minus 5 step he is making behind from there only. And he is going somewhere. If n is 5, then he is making 5 step and he stops. If n is 10, then 5 step he is moving forward and 5 step he is moving backward, whatever it is. Now he is trying, what is the average position of that person, when, what is his average position of that person when he is trying many times. Makes sense? First time he tried and he moved forward and backward. Now he has one position. He tried again. Now he moved forward and backward. Now he tried again. What is his average position after some number of tries? That is the question now. Okay. Now to this question, n number of tries. Now consider that I believe a similar question we solved in the previous session. There we had a C amount of money and money is becoming doubled if there is head and money is becoming 1 by 2 if it is 10. It keeps doubling. This is called geometrical progression. It comes under, we will talk about it. There is something called and or. In probability is a game of and or. If someone understand very minutely and or, he will crack the probability. The way I say that electronics is game of resistance. If you understand the minuteness in resistance, because voltage can be only of two types. Voltage can be only of two types. Either it is a static voltage or it is a variable voltage. Okay, voltage can vary, like AC voltage. Voltage will vary, voltage will go up, then it will come to 0. Then voltage, the polarity of the battery will switch its polarity. And voltage will go in negative, means the battery of the polarity of a battery will switch its polarity. It will consider as voltage going negative. So voltage can be either move in that fashion or it will be static. In that fashion, how that we can measure the current? Now it depends upon the nature of resistance. If someone monitor the nature of resistance, if I have a very complicated circuit, at the end, full complicated circuit, you draw as a resistor model. Resistor model can come into a very complex algebraic equation. It can come as in x, y, z. I'm sorry. Okay, resistance is something like that. Is a 2t. 2t means at time is varying. resistance is varying double of it, or resistance is variable of the heat. So resistance is 2 into heat. You grow the heat, then resistance will vary like that. You reduce the heat, thermoresistance. Or resistor can be x square plus log x square plus log by plus there are so many components in resistor. But I have circuit and I expect resistance to be some numerical value or varying numerical value, but it can have many orthogonal components also. It can be very complex. Resistor can be very complex. In that fashion, the current will show very different behavior. So electronic circuit is a game of resistance. In that fashion, probability statistics and artificial intelligence or machine learning, it sits on technology called probability and stochastic theorem. Probability and stochastic theorem is a topic generally people study. Probability and stochastic. It is sitting on top of it. And it is very, very extremely miniature science. Extremely miniature science. No, in that fashion, our channel name is meaning only, miniature science. Anyway, now what is the expectation of a person after so many tries that where he would be standing on this axis? Okay, initially he was at origin, and after n number of n coins thrown, then he walked front and back, and he is at one location. Okay, then again try, then he start from zero again, and then he is at another location. What is the average value? Sometime he will be along positive axis, sometime he will be along negative axis, sometime he will be here, there. Now measure add all the distances. This distance will be negative, this distance will be positive. Divide it by number of try you make. Okay, and then calculate the average. Now it will come as like, what is the probability? It is a fair coin. The coin is fair. Okay, in that fashion, if I throw n number of coins, getting a k number of head, the probability one head, all heads are one head has probability of p. Consider p, that is 1 by 2. If I toss a coin, getting head or tail, probability is 1 by 2, 1 by 2. Okay, in that fashion, if I throw n number of coin, getting a k number of head, k number of head can be in any place. If n number of coin are arranged in a serial position, 1, 2, 3, in a one line, then k number of head can be anywhere. Consider any k number of head in any combination. Then what is the probability of getting k number of head? If one head probability is 1 by 2, then 1 by 2 into to the power k. What is probability of getting tail then? 1 minus 1 by 2. That is 1 by 2 into n minus k. Okay, net probability of getting head is 1 by 2 to the power k, 1 minus 1 by 2 into n minus k. Now number of this head, k head, can be in any position in the n coin. Beginning head, k head, end k head, they are distributed as kind of in a non-continuous manner, randomly. So if I take all permutation, it will be NCK, NCK, n combination of k, that is factorial of n by factorial of k into factorial of n minus k, NCK, NCK, p to the power k, I'm sorry, 1 by 2 to the power k, 1 by 2 to the power n minus k. If someone add, it will become 1 by 2 to the power n only, whatever it is, but depends upon p. Consider it is p. It is a initially I said fair coin. Consider it is p. It is not a fair coin. Means for the specific. So now it is p to the power k, 1 minus p to the power n minus k, nck. Okay. Now I'm trying to get the average value. This is the probability if the number of head is 1, number of head is 0, number of head is 1, number of head is 2, number of head is 3. It is something like that. If I'm cutting down a stick, then what is the probability or number of a stick when it is in section number 1? This is the probability. Remember, what is probability of the stick if it is in section number 2? How many sticks are there? Divide by alpha. Similarly, if number of head is 1, then what is its probability? Makes sense? That is nck p to the power k, n minus p to the power n minus, sorry, 1 minus p to the power n minus k. So at any k, that is the probability. So k into its probability. So if k is 1, then it is 1 into nc1 p to the power 1, 1 minus p to the power n minus 1 plus k equal to 2, then nc2 p to the power 2, 1 minus p to the power n minus 2 plus k equal to 3. If I add this, then I get the if I add all this, then I get the number of head, average head. What is the number of average head I am getting? Makes sense? The way I was calculating what is the average length of the stick. Here, what is the average number of head I am getting? Now multiply it. Whatever head I am getting, number of head, multiply it by 1 because I am moving one step. If a number of average head is coming as, if there are n coin and number of average head is coming as n by 3, then he is making n by 3 into one step forward. Makes sense? Now similarly, calculate the number of average tail and then add it. For number of average tail, you have to multiply by -1. This is extremely difficult solution. Someone try to find summation k equal to 0 to 1. Summation k equal to 0 to 1. And then k into 1, because one step he will make forward. K into 1. And then it is nck p to the power k n minus p, 1 minus p to the power n minus k. This is the net step he made the forward. Okay, plus k equal to 0 to 1 minus 1 into k nck p to the power n minus k, 1 minus p to the power k. This is the average tail into -1. This is the average distance he made. The way we calculate the average length of the stick. Is there simple solution to it? The simple solution to it is that now there are n number of coins. Can we calculate coin by coin? Because all are independent to each other. If I throw n number of coins, each coin's outcome is independent of the first coin. Second coin outcome is independent of the first coin. All are these. This is typically called identically. I'm sorry. It is called IID, identical independent distribution. They are divided into n number of parts and all are independent and identical. In that fashion, let's calculate the, if it is same as he has n coin. Now first coin he toss it, and if he gets, he move one step forward or one step backward. If it gets 10, he throw the coin. Job is over. Next coin he is trying, same thing. Makes sense? Now trying for the n number of coin, he keep the n number of coin in his hand. First coin he tried. Okay, then if it is head, then he is proceeding. Tail, he is going backward, throwing the coin. Now next coin he is trying. Now n number of coin he tries, then he will see what is his position. That will also come as the average position. Okay, now let's try. Okay, first coin if he is trying, then what is the probability that it will be head? That is P. Tail is 1 minus P. Okay, if that is the case, if it is P, then another is 1 minus P. Okay, now there is no point in trying head for 0 times. 0 times it will be, now the how much he will move forward. What is the probability? That is 1 into k into nck, that is the distribution. 1 into k into nck p to the power k, 1 minus p to the power 1 minus k, because maximum he is trying one time only. Anyway, so if I say k equal to 0, then full will become 0. No point in calculating. K equal to 1, because anyway he is trying one time only. So for one case only we will try. Now it will become 1 into k. K is 1. 1 into 1. 1c1 gone, 1. P to the power 1. 1 minus p to the power 0. That will become p. Means he is making p forward. The probability of making forward for with one coin is how many steps he is making forward is 1 by p, half a step. What is probability of getting backward with one coin? Then it will be minus 1 into k nc k p to the power n minus k 1 minus p to the power k. That will be for k equal to 1 minus 1 into 1 nc1 1 p to the power, so that will be 0. 1 minus p to the power 1 minus p 1 minus p to the power 1. It will become minus 1 into 1 minus p. It will become p minus 1. Now we have to add both. For one coin, where he will be? If he toss one coin, then what is the average move he will make? That is p plus p minus 1. If I add, it will become 2p minus 1. Now, if I move n distance, that will be n 2p minus 1. N, if he has n coin, n into and then 2p minus 1. That much is the average distance that he would travel. In the past video, we did whatever we calculated, we did the power of n. Here we are multiplying by n. This is considered as an OR relationship. And last one, it was considered as AND relationship. AND relationship where we want geometric progression, or relationship where we want arithmetic progression. Okay, this is something that we have taken a measure where rather than going as a big solution, we are coming to a smaller solution, but all we are doing in discrete manner. Okay, we will take tougher example also where successfully we are able to solve into discrete manner by dividing into n part, and then how if n tends to infinity, then how we will bring it to integral calculus. Some discussion we have already made it, like summation of a series, like 1 by 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, that is 1 by 2 to the power x. Or we have 1 by x, 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Those things we have talked. So here we successfully solved our problem by dividing the problem into n parts. How to solve a problem? By dividing the problem into n parts. Solve part by part, solve part by part, and then add it. Addition is all right if n, I know, if n tends to infinity, then what will happen? So this scenario will take another examples also, and we'll talk more about and or relationship. That is the core of probability. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone.